Next is level 3 and 3.1. So what we want to do is concentrate first on making our code base more agile, adding that technical capability to increase business capability, right? More features for, quicker, like easier ways of doing it. So for example, the bookmarks, you want to design the bookmark system so that it can now be, cross-device, for example. Technical capability extensible 3.1 would mean that you're going to take that bookmarks and not only make it, cross-platform and so on, but other people can actually embed or do a plug-in to that bookmark and add more metadata or add something else to that bookmark. And so that's the logical design maturity of any application. If you think about this as the life cycle or the lifespan of a product, you're going to start off by just reaching the goal and solving some problems, and then you're going to have a time of technical capability and increasing that and trying to get all your code in order, and then you might need to reach and solve a new goal, and so this isn't linear. This is going to be happening all at once. One person on the team is doing reachable solving while you're busy doing some minimal maintainable and some design work for some other feature, and so this is asynchronous, different devs doing this at different times. And what's important here is that we move from level 1 to 3.1. Now we can stop at 3. 3 is an absolutely legitimate place to stop, right? We don't need extensible components and plugins and so on. But if you're stopping on 2 all the time, you're not realizing pure agility in code, right? That is very, very, very valuable to a business, to being able to adapt code rather quickly, making code agile. So here I have, so it's a big screen, lots of icons, looks very busy, but don't worry. On the left here, this is just the whole kind of infographic all in one thing. And then I've divided it up. Top half on the left here, in the middle, and on the right I've got the bottom half. And let's just have a look at this part here, the middle section maturity index quickly. And you'll see that I've got reachable over here, and I've got solvable level 1. You can see there it is. Level 2, you can see I've got minimal, maintainable, environmental, and level 3, the agile and extensible. So a greenfield project, well, let's see how it maps. So we've got a greenfield project. What do we want to do? Reachable, solvable, and minimal. So a greenfield project, we might decide these are the 3 things that kind of fit into our greenfield. This is what we want to start off doing. We often want a minimal approach and see where we get to. So we might just start off on that. If the application already exists, right, and there it is, and now you're going to apply Ammerse and have a look, well, what you're going to do is you could basically take all 7 principles, but you might be applying them to different areas in different ways. And that's what I mentioned about weights. We might say that reachable and solvable is very important here, but we do want environmentally as well. So please, if it takes a little bit longer, but it's environmentally friendly, please go ahead. We might say that we want maintainable and agile, and those are the most important things for one section, but it's not for the other section, so you can make a decision. So here's a framework. That would be a white box, that's a gray box, that's a black box. A prototype, well, what you want to do, well, you just want to reach it, right? You just want to reach it, and you want to reach something, right? Whatever that might be. It might be a requirement, just reach that requirement. Build some kind of prototype and see how far you get. A minimal viable product might be, you want to have a minimal maintainable solving solution, for example. It's your choice what you're applying there. If you said it's reachable, solvable, that's your MVP, well, so be it. If you use all 7 principles, well, then that's your MVP, and now you have the vision for where you want to be, and all the devs will understand what that means. Remember, each principle is also a category, and we'll dive further into that. And if I want to build an ecosystem, right, I want people to write code and submit plugins and all that, I need an extensible, and I need it to be environmentally friendly, and so that's an ecosystem. So let's have a look at the bottom half and have a look at you'll see here I've got an arc. And this arc here, this is basically showing all the principles as they increase in difficulty, as the level 1, 2, and 3 emerges from this design. So we start off with reachable and solve, and we're always nudged to solve that problem. So I just put it in there. So we're going to reach it, but we're nudging, oh, we really like to solve all the problems. Now sometimes we can't reach it because we're trying to solve more than we thought, and so on. But that's what we're trying to get to. And then we want to look at minimal. We want to make good decisions here. We want to make really, really good decisions on how to make our code minimal. Then we want to refine it with maintainable, and we want to get it environmentally friendly, and that reaches us to level 2. But it gets a lot steeper to get agile code and extensible code. And this here is where the sort of line, I feel, is for emergent design. I think once you're doing reachable and solvable and you're just knocking things about, and you maintain your code, make it a bit more maintainable, and you write some more tests and you do tests first maybe. This area here, I can see that many techniques will work quite well if you follow 1, 2, 1, 2, 1, 2, write some code, optimize it, write some code, optimize it, and so on. You shove testing in here. Regression testing, integration testing, you add a QA to make sure that minimal code and maintainable code is really good. Well, yeah, you're going to get some nice quality, but you're not necessarily going to reach this part here. And this part is usually something where you actively sit down yourself, a team, a designer, an architect, and so on, and say, how do we get this problem solved? And you go through the various options, and you might need to draw that out. You might need to evaluate that. You might need to do a prototype with that solution, a prototype with that solution. You might have to dead end that particular prototype and say it's worthless to us. We're going on this route. And that is why actively designing to get to that point is quite necessary. If you're in a very small team, you can move through all of this. If you've got the design knowledge, you can move through all of this and you'll get to the other end over there. But you will get, in doing this, a lot of refactoring. And so sometimes it's really useful going to 3.1 immediately, or understanding that the core feature or a core piece of functionality that you have in your app requires level 3 or 3.1 immediately. So let's not do reachable, solvable. Let's not then refactor to minimal and then give it some maintainability and then document it and get everybody on board environmentally and consolidate the design. And you don't want to go through all of that. You want to hit it straight off the bat, right? You want to jump there and say, look, I'm going to do 80% of this design right now. I know what it needs. I'm going to build that, and we'll emerge the other 20%. Okay, so this is the maturity index, and this is how I think about design and how people should communicate their intentions, and kind of give you a clue on how you can map these 7 principles on different terminologies that are out there, and how useful it might be if you decide on one or more of these principles as being your guiding set of principles. So how does it help? Well, it fosters design thinking. It helps architects declare design intentions, constraints, and vision. It aids the design documentation. It helps contextualize patterns and heuristics at a higher level. I'm going to go through that very soon. So how does it aid documentation? Well, if you've got a bookmarks feature and it says 3.1, well, you already know what the design's going to be. You already know it's going to be extensible. It's going to be agile. You're going to be able to plug different things in. There has to be a certain understanding that goes with that 3.1. And so sometimes it's kind of like the definition of done in a loose sense. I really hate that term, but it is in the sense that you still have to define what 3 and 3.1 actually means to you. However, I've done a good job of laying out what I think it should mean. And so if everyone's on the same page, then you'll get better documentation, better vision, and so on, rather than always describing it again and again. You move from one company to another, you'll have to change your definition. I think it will work much better when the definition is solid. There's a low learning curve to Ammerse. It's quite easy. It's 7. It's Ammerse, right? It's agile, maintainable, minimal, environmental, reachable, solvable, extensible. It's easy. You can learn that quite quickly. Low learning curve. The principles are quite easy. If I said, reachable and solvable, right now after watching this, if I said that's the only thing you need to understand, right now, go and build that. I need a reachable, solvable, please. Like, absolutely what I mean already. So it's a really low learning curve, and it's quite fundamental to not doing it wrong, right? Not over-engineering, if we said that. This is throwaway code, reachable, solvable, right? You just absolutely know what that means. And you can make it as advanced as you want it to be. So you could say, look, I want the bookmark feature. I'm going to divide it up into 2 sections. The bookmark itself, with its icon, its title, the URL, I want that to be completely customizable. I want it to be, we're going to add many types of bookmarks for different systems, bookmarks to URLs, bookmarks to document pages in a PDF. It's a universal bookmark, right? Compared to, it's just a bookmark in the actual browser doing what the browser does. So, you could say that by saying, look, this is an agile and extensible bookmark system. And straight away you would gather what kind of design thinking you need to apply to that feature. Okay, so let me skip that, go through to the next, skip that one. I'll come back to some of these. Where does this live? So Ammerse is something that can be used for developers to make good decisions on their code. It's also the design and how you map Ammerse onto an existing design, right? So now developers can see Ammerse in the design. It's also enterprise architecture, can communicate via Ammerse to architects and business units, right? So, if everyone in the business understood what different feature sets and capabilities there might be for a particular thing, you can have a good vision and understanding. And this could be for anything. I want to roll out email, to this organization, in a different way. I want to roll out a ticketing system. It's not code we're writing. We just want to roll it out. I want level 3, right? I want level 2. What does that kind of mean, level 2, if you don't even have the code? Well, it means that their code base should be at least that level. If I said 3.1, then I really truly want an extensible system that we can write code and dive into their environment and add plugins. And that's a whole different way of looking at Ammerse and looking how you can use that within dependency, searching for dependencies, evaluating dependencies. Okay, so I'm going to leave it there, and this is where we will start for the next video. We're going to be talking about agile, minimal, maintainable, environmental, reachable, solvable, extensible. Thanks for watching. See you next time.